Polygons. What makes a polygon? By definition, we're going to have at least 3 sides. And the reason we need at least 3 sides is because the polygons must be closed, meaning there's no gaps between our edges. Then the sides must be straight. And the only place these edges intersect are at the vertices of our angles. So the simplest form of a polygon is a triangle. So I need at least 3 sides, because if I only had 2, or if I only had 1, I would be unable to close the figure. But as soon as I introduce a 3rd side, we're able to close. All edges are straight, and the only place they intersect are at these vertices, which we'll label A, B, and C. Now, what do I mean by only intersecting at the vertices? If we had something like this, where let's say we think of this as having 4 edges, where this edge AC is crossing the edge BD at this point E, we'll call. The reason why we're not going to classify that as a polygon is because we could just instead classify that as 2 polygons put together at a common vertex point, or 2 triangles. Okay, so we're going to remove from the definition that the edges could overlap each other, but rather their only intersection point is at the vertices. Now, speaking of edges and vertices, the edges are the sides, so that's an edge. The vertex is where the edges meet, and we have angles at those vertex. Now, within each polygon, we have interior angles. So for that triangle, we have angle 1, 2, 3, or angle A, B, and C, are interior angles. And we also have exterior angles, where those are formed when extending out the side so that a new angle is formed that is a linear pair with that interior angle. So we could say angle 4, there's exterior. We could extend that side, get another, extend this side for another, or we could have extended them in another way. So we could say we have 7 here, 8, whatever. We could extend a side to create an exterior angle. Now, speaking of angles and sides, there's some other vocabulary we want to be aware of, and that is regular versus irregular. So what makes a regular polygon? Well, regular refers to all sides and all angles are congruent. So if that's the case, we have regular. Now, what makes irregular? Well, it's not regular. So not all sides and not all angles are congruent. So if we have the vocab term regular thrown in with our polygon, where we have a regular triangle, we have a regular quadrilateral referring to 4 sides, then we know all the sides, all the angles are congruent. So now, the last bit of vocab to introduce polygons would be concave versus convex. And this is going to involve the idea of a diagonal. So concave and convex, with the diagonal, let's draw an example of a convex polygon. Actually, let's introduce more sides. So let's do a pentagon here. So we have 5 sides. So 5 sides. Now, what makes it convex? Well, first, we have to know what a diagonal is. So a diagonal is a line that connects non-consecutive vertices. So the line that connects consecutive vertices is the edge. But if I draw a line from one vertex to another that's not directly next to each other, I've just drawn a diagonal. Now, the diagonal, if every single diagonal is on the interior, is convex. So we're going to say all diagonals are on the interior. So again, the diagonal is the line connecting non-consecutive vertices. So let's try to draw all of them. So it looks like there's 2 from each vertex. Some we've already drawn. It looks like all of them. So every single one was on the interior. Every possible diagonal that could be drawn was on the inside. So that shape is convex. Now, what makes something concave? Well, concave is going to be if we can just find one diagonal, that's all it takes, one diagonal that is on the exterior. So let's say we have this star shape. We can see that it's a polygon. So the diagonals, again, are the lines that connect non-consecutive vertices. So immediately, if I take this vertex and connect them, we have a diagonal that occurs on the exterior. So not all diagonals are on the interior, and therefore it's concave. Another way to think about it is if, imagine we had this as the original side, and it looks like that side got caved in. So you knocked it in to get this bend in that side. So concave, think about caving in a side. But the more formal definition is going to be at least one. Oh, we don't want that. Dotted. On the exterior. So we have definition of the polygon. We've introduced regular versus irregular. We now have concave, convex. And the last thing we'll say before we jump into more videos related to this topic is the most important polygon, which we drew originally, the triangle. The triangle is the most important polygon because due to the fact that all polygons are formed by straight edges, we can subdivide all of our polygons into triangles. So understanding the triangle is essentially understanding high school geometry, okay? Especially the polygons and quadrilaterals unit that we are going to cover. So subdividing, if I introduce 4 sides, I can divide it into 2 triangles. If I introduce 5 sides, the pentagon, we can divide it into 3 triangles, and so on and so forth. So understanding the triangle is going to lead to some nice properties and a better understanding of polygons that have more than 3 sides. So that is the conclusion to the intro to polygons.